Alright guys, welcome to my YouTube channel, Dr. Oresco. My name still remains Favor. Please do well to subscribe. Today we'll be looking at the introduction to organic chemistry, and our topic today is hydrocarbon. What are hydrocarbons? The name has already spelled it out. Hydrogen, hydrocarbon. Hydrocarbons are binary compounds. Binary compounds consisting of hydrogen and carbon only. That is what hydrocarbon is. And the main source of hydrocarbon is crude oil. That's the chief source of hydrocarbon. What is crude oil? Crude oil is a dark, thick, and viscous fluid or mixture. Okay, it's a thick, dark, and viscous mixture. That is crude oil, and that is the main source of hydrocarbon. It consists of constituents or fractions such as alkanes, cycloalkanes, and the rest, and even many other components. So this crude oil is actually in the raw state. It is not useful. So it is actually subjected to treatments or separation processes to be able to remove those components that are useful. Now, before we look at crude oil, let's see how hydrocarbons are classified. So let's look at the classification of hydrocarbons. Hydrocarbons are chiefly classified into two. We have the aliphatic hydrocarbons and we have the aromatic hydrocarbons. The aliphatic hydrocarbons, these are hydrocarbons that are in straight chains or cyclic chains. They could either be straight or in cyclic form. But when you look at the aromatic hydrocarbons, they have the benzene ring in them. There's that benzene ring in them. A good example is benzene, toluene, xylene. All these are aromatic hydrocarbons. So the aliphatic hydrocarbon is further divided into acyclic, and then the cyclic hydrocarbon. Acyclic means there is no cycle, it's just a straight shape. While cyclic means it is circular, there's a circular shape. So for the acyclic, there are basically two. We have alkanes. We have, an example of an alkane is methane. Alright, CH4. Then we have alkenes, e.g., ethene. Then we have alkynes. Okay, an example is ethyne. So here we have ethene. Here we have ethyne. Then for the cyclic aliphatic hydrocarbon, these are having a cyclic, a kind of a cycle. There is like a cycle. An example is your cycloalkanes, such as cyclopropane. Okay, cyclopropane is a good example of a cyclic aliphatic hydrocarbon. Then let's look at the aromatic hydrocarbon. We said they are usually the arenes. And what are the arenes? They are the benzene, toluene, phenol. So Eg is benzene. All right. So this is just a brief classification of the hydrocarbons. Then let's look at a brief history of crude oil in Nigeria. Crude oil in Nigeria. What are the points you should take note? One, crude oil was first discovered in Nigeria in 1956, where at Olobiri, Ogbia local government area of Bayelsa State. Bayelsa State. Number 3, Nigeria crude oil is referred to as sweet oil. Sweet oil. Why? Because of its low sulfur content. Nigeria crude oil is sweet because it has a low sulfur content. So, this is a brief tour to crude oil in Nigeria. So, how is crude oil processed? Remember I said earlier on that crude oil is a mixture. A mixture meaning that there are different things that are found in it. So, and in the natural or the normal state, it is almost useless. So it has to be first processed, or rather first separated, then processed. So in the separation of crude oil, the technique used is known as the fractional distillation. So we are looking at now the fractional distillation of crude oil. Fractional distillation of crude oil. Now, fractional distillation uses the principle of the differences in boiling points in those fractions that are inside the mixture. The differences in the boiling points. So, what we mean is that, let's say a mixture comprises fractions like fraction A, fraction B, fraction C. This is now a mixture. Okay, this is the jar or the column where the mixture is poured into and to be subjected to heat. When you heat the mixture, let's say fraction A has a boiling point of 10 degrees Celsius, B is 20 Celsius, and C is 30 degrees Celsius. The principle here is that there is a difference in boiling points. That's one. Secondly, the ones that have the lowest boiling point will come out first. That means they are going to be distilled over first. So they distill over in increasing order of their boiling point, starting with the one with lower boiling point, and then finally the ones with the higher boiling point. So it is to be expected that when this fraction here is subjected to fractional distillation, that is when you heat it, gas A or fraction A will first be collected. Alright. Having said that, this is actually how crude oil is. They are processed in columns, big tanks, and they are then subjected to high temperature. So, what are the fractions that are gotten? The first fraction to be gotten from the fractional distillation of crude oil is natural gas. Natural gas. Alright? So, it is imperative that you know the fractions and their respective temperatures where they are collected. So, natural gas is collected at a temperature of less than 40 degrees Celsius. So, between any range of 20, 30, they are collected already. And the major constituent of natural gas is methane. Methane is a major constituent of natural gas. The second fraction collected is gasoline. Gasoline otherwise called petrol. It distills over at temperatures of between 40 degrees Celsius to 200 degrees Celsius. Okay, so number 3 is kerosene, which distills over at temperatures of 200 to 250 degrees Celsius. That is then followed by oil, lubricating oil. Okay, just continue from 250, so about 250 to 350 degrees Celsius. Then we now have the last one, which is bitumen. They are usually collected between, just say, greater than 500 degrees Celsius, so anything above 500. So, which means that these ones, they are so large that the largest component in terms of the fractional distillation of oil, they are the last to be distilled from the container or the vessel, the distillating the container. Now, after we have separated crude oil, so how is, because the first thing is we have drilled the oil, they are drilled from the soil, from the earth. Then we have subjected them to distillation. That is to separate this oil into the different components, such as natural gas, kerosene, and the rest. There are some fractions that are not still useful at this stage, because when we have gotten this product now, some fractions will usually have higher carbon content of greater than 60. So those ones are usually less useful. So what happens? Should they be wasted? No. They are going to be subjected to a treatment that will make them to have a lower carbon content. In other words, we are breaking them from larger molecules to smaller molecules. Then secondly, you are making them, you are changing them from their less useful state to a more useful state by the process known as cracking. So cracking is the breakdown of larger and less useful hydrocarbons to smaller and more useful products. There are two ways it is achieved. We have thermal cracking and we have what? Catalytic cracking. The name means a catalyst is usually what? Employed. Catalytic cracking. Okay. Usually the catalytic cracking is most efficient, is better compared to thermal, but in terms of cost, it's actually more expensive. Alright. So in this process now, we have been able to refine or make the oil more useful. Let's now look at the ideal petrol. Ideal petrol. Ideal engine petrol. For a petrol to be ideal, one, it must not burn too rapidly. Then two, it must not also burn too slowly. It must just be in between. So if it burns too fast, it will cause knocking, to cause pinking sounds, to cause decreased efficiency of that machine, and to cause friction. But if it burns too slow, it will lead to incomplete combustion that will result in smoky flame, and the end result is air pollution, because those flames, those soot will be deposited in the atmosphere. So, one, for petrol to have a good quality, so one is, if the petrol is if it is too volatile, Volatility means it is light and it can easily burn and easily kind of escape. It has very high kinetic energy. So if it is too volatile, it means that that petrol we have very high, very low ignition rather, low ignition. And when it has low ignition, it means it will burn prematurely. To burn prematurely. Prematurely means it will burn very fast. Very fast. So if it burns prematurely, it means it will cause knocking of the engine. Okay? The engine has gone knocked. If it causes knocking, there will be pinking sounds. There will be pinking sounds associated with that knocking. Alright? That's when you hear your car engine. You are using the wrong oil. Oil is very volatile and has a very low ignition number, causing knocking and also a pinking sound. This pinking sound will lead to a decreased efficiency of the engine. A decreased efficiency. And that is as a result of what? Friction. So there is actually friction occurring. So this is one problem. So this cannot be considered an ideal engine oil. Why? It is too volatile, causing a decreased ignition number and an end result of what? Knocking. So know that too volatile an oil or a petrol will cause knocking associated with pinking sounds. The opposite is if the volatility is low, less volatile, what happens is that it will not burn completely. So this will not lead to incomplete, because for the too volatile, it was burning very fast. But here now it burns so slow that it will not be complete. So incomplete combustion. And when there is incomplete combustion, it will deposit smoke. That will not cause air pollution. So an ideal engine oil must not be too volatile and must have a good range in between, not too high, not too low, so that it will not burn partially and it will not burn incompletely, and so that we avoid causing knocking and avoid causing air pollution. So either of these two is a problem. So which petrol is able to suit an ideal engine, to be called ideal engine is this petrol. So petrol is ideal because it does not have this high volatility or lesser volatility. So let us look at octane number system. Octane number system. Octane number system. The octane number system is a system of grading the quality of petrol, knowing the grade or the quality of petrol, whether it is good or bad, all right? And it's usually rated from 0 to 100. So what is the principle here? One, the petrol that have just straight shades, no branching points, they have low octane number value. Just straight, they don't have branching points. Then two, petrol that have branching points, that means the higher or the more the branching point, the better that octane number of such petrol. Taking for instance, we have heptane. Heptane is 1, 2, 3, 4, 5, 6, 7. It's the 7th homologue of alkane. Okay, so we have all these are hydrogen atoms. Hydrogen atoms. 1, 2, 3, 4, 5, 6, 7. These heptane. Then number 2 we have 2, 2, 4 trimethyl pentane. It's also an alkane, but has branching point at second carbon atom. So how do we write this? First of all, look at the name, pentane. So we have 5. 1, 2, 3, 4, 5. 2, 2, 4, which means at position 2, 1, 2. There's a methyl group there. This is a methyl group. Another methyl group up. 2, 2, 2, then 4. Another methyl group here. So we now fill in with hydrogen atoms. So these are 2 examples used to buttress or to explain the octane number system using branched and unbranched compounds. So for this heptane, if you want, it's just a straight shape. There is no branching point. It will have an octane number value of 0. Why? No branching. But this one has some branching point. So it has an octane number of 100. So you should take note of this example here. 2,2,4 trimethyl pentane has a good octane number system. It's a very good petrol with an octane rating system of 100. So the more the branching, the higher the quality. So the quality of octane number system is directly proportional to the branching. Increased branchings, increased quality, and vice versa. Another thing that also determines the octane number system is the molecular mass. So number 1 was what? Number 1 determinant was determinant of octane number system. So the first one we looked at was 1. The branching was branching. Okay, when we now see that if it is highly branched, it has a higher octane number system. If it is not having branch points, it will have a low rating system. The second factor here is the molecular mass. Molecular mass. And the octane number system is inversely proportional to the molecular mass. Meaning that, let's say we have a petrol A, petrol B, petrol C. These are the petrols. So petrol here. These are petrol A, B, C. Then their molecular mass for A is 20, B is 35, and C is 100. Then here is that the octane rating, the rating system. Okay, the octane rating. So we said that the octane number is inversely proportional to the molecular mass, meaning that those that have high molecular mass will what? Have a low rating. So what will happen here is that this one that has the highest molecular mass, we have the least. While this one that has the lowest molecular mass is the best. So this one that's in between will also be average. Okay, that is about the octane number system. Okay, now let's also now look at petrochemicals. Petrochemicals are compounds or substances that are gotten from the byproduct of petrol or crude oil. Examples we have detergents, We have plastics, we have nylon, and we also have fertilizers. So, guys, this has made us understand the concept of hydrocarbons, that they are binary compounds, their classification into aliphatic and aromatic, and again aliphatic further being classified into cyclic and acyclic. Then we now look at that petrol in Nigeria is actually of a low sulfur content, which gives it that name, sweet petrol. Alright, then we talk about the brief history that it was discovered in 1956 in Oloibiri of Guyana province of Bayelsa State. We also looked at the process of separating crude oil, which is the fractional distillation, and it is based on what? Increasing order of the boiling point. Then